welcome to Wildly Curious, a podcast that tells you everything you need to know about nature, and probably more than you wanted to know. I'm Laura.
And I'm Katy, and I am so excited for this episode.
This is finally your episode.
This is finally my episode of dinosaurs, guys.
You're
We're going to be talking about, dinosaur discoveries and just how it's kind of evolved throughout history and how it just continues to challenge, everything that we thought we knew, revealing just how complex and diverse everything dinosaurs is compared to what Hollywood makes it out to be. As much as I love the Jurassic Park movies.
Yeah. Well, and I think that I talk about it a little right here when we get started, but in general, I think dinosaurs is what makes science so amazing and really shows what science is, right? It's constantly reevaluating our assumptions with new evidence, and then here we go again. It's just constantly changing.
Yeah, it's constantly changing, but then it's just, I feel like it's the gateway drug to science for so many people.
I agree.
Because it's what you get into as a little kid. Oddly enough, I didn't get into it as a little kid. It really hit hard whenever I got my first job at a museum. And I had to actually learn about all this stuff to give tours and everything. Then I was like, ADHD kicks in.
That's
Heck
crazy.
yes,
I had
deep
no
dive
idea
into dinos.
that the dinosaur bug didn't hit you till that late in life. That is crazy.
No, right? And because I was like monkeys and gorillas and wolves.
That's true. You devoted your whole life. Yeah. You're the primate person.
So I was all the other animals that I just never really I always thought, okay, cool, dinosaurs, but it wasn't. I didn't do a deep dive until really college.
Yeah.
So this is gonna be a big episode, guys. Again, so excited, but I do have some interesting nature news.
All right.
That I came across. So this one's pretty quick. It was found in Nat Geo by Jason Biddle, who wrote it, and it's some beaver news, and it's pretty damn impressive.
Oh my gosh.
But so in the Czech Republic, there's been a long-standing plan to build a dam, but as with many big projects, it hit a few snags, got delayed, and it just kept being pushed back. Enter furry friends, aka the beavers.
They built the dam for them?
So while the humans are stuck in planning mode, a family of beavers just took matters into their own. Do they have hands, paws?
Yeah.
What are they considered?
Hands. I don't know. You probably call them paws, but they're pretty hand-like.
Yeah, they are. They really are. So in basically what seemed no time at all, they just started to build their own dam in the exact spot where the human man-made one was supposed to go, which saved the Czech government about $1.2 million.
Daggone. At least the preliminary dam, now that they're like, well, the water flow has already been cut off, I guess we can just go ahead and do it.
Right?
The beavers were like, thank you.
Yeah, right.
I saw a waterway and I needed it to stop.
Yeah, right. So there's more in this story, but if you guys go check it out on Nat Geo, it's called "These Eager Beavers Save the Czech Government $1.2 million" by Jason Biddle. So
That's
shout
awesome.
out to Jason. It was a pretty funny article.
I do love a good punny beaver article. There was a really interesting webinar the other day that was about beavers. Then some of it was on point as far as puns.
Okay, so I work for local government, and if I could just hire a team of beavers to get some stuff done.
Oh yeah. I need the diligence of some beavers, for sure.
Right? But even just how funny that would be. Like, guys, it's taken us so long to do this stuff, but beavers got it done faster than the government.
I love so much the meme trend of beavers being just anything about water flow and then stopping it. It's just like a constant meme train. My favorite one that I saw recently was the movie cover for A River Runs Through It. But a beaver is like busting through the cover, and it's the hell it does. Or a river ran through it.
Yeah, I saw that one too. That was a good one.
All right.
But yeah, so $1.2 million, and it got done way faster. So way to go, beavers.
Meanwhile, they're causing my city to pay tons of money in damages.
Oh, really?
Yeah.
In damages, yeah.
For flooding and things.
They're just over-eager beavers where you are.
Beavers.
Those
gotta rein it back in a little bit.
Yeah, we'll phone a friend in the Czech and have those beavers
come
talk
get our
to
beavers.
the Czech beavers. Yeah, right.
Rent a beaver? Wait, that. Yeah. Not gonna get in there. Let's talk about dinosaurs. Okay. So
dinosaurs. So like we said, this is gonna be kind of a bigger episode. We're gonna try to break it down into a few different segments. give a brief introduction, and then we're going to go into what is a dinosaur, when did they live, and what makes them unique. And then Laura and I are each going to take a chunk, and we're going to debunk some of the more popular dinosaur myths. There's tons of them. Yeah. So we just picked one each, and then we're just going to go.
We're just going to bounce this ball back and forth so you don't get tired of one person talking.
Yeah. Because there's a lot. We tried to split it up a little bit. So yeah, we'll see how this goes. So Laura's going to kick it off here, though.
I think it's going to be great. With why the fascination with dinosaurs, okay? And let's be real, we've all gone through our dino phase. If it was like Katy, it was late in life. If it was like Laura, it was probably around 2nd grade, maybe a little earlier. And it wasn't like full-on dino kid, like I wasn't running, well, no, I was running around like a dinosaur. But,
I was gonna say.
I mean, not a lot of like dinosaur stuff. Like I didn't have the clothes. Yeah. I wasn't fully into it, but I specifically remember certain dinosaur books that my 2nd grade teacher had, and of course The Land Before Time, and we were playing it at recess. Like we all had our favorite dinosaur, you know.
Jurassic Park, who traumatized us all because it was so good, but so terrifying.
Yes. Why do humans love dinosaurs so much? For a few reasons, probably. One, there's something that everyone is drawn to with a large, charismatic megafauna. Today, it's elephants and tigers and things. But nothing is bigger and crazier than giant, powerful dinosaurs. So that is the biggest, most charismatic megafauna. We just don't even know really what they specifically looked like. And because of that, because we don't know everything about them, there's so much that's left to our imaginations that we all love to solve a good mystery and think of, well, what could it have been? Like,
yeah, we all fill in the blanks.
Yeah, and tell our own like, stories.
What would be perfect. Yeah.
And it's an important link to our past, so people like to understand where we've come from as far as human origins and before. What do you think Earth was like? What do you think it was like to live back then? What would it have been like to live with dinosaurs? That sort of linking us back. And then, of course, what makes people truly obsessed with things typically is pop culture.
Dr. Alan Grant.
Yeah.
No, okay, go ahead.
I mean, yes. Pop culture. So since the discovery of the T-Rex and the Triceratops, dinosaurs, we've talked about this before in our past fossil episodes, dinosaurs have been around for a very long time. People have discovered them a long time ago. They just didn't know what they were. But things really kicked off when they found T-Rex and Triceratops in the early 1900s. And since then, they have been a part of our culture. One of the first major representations of them was in 1925 in The Lost World, based on the book. That's 1925 in the movies.
Yeah.
I can't even imagine what they must have looked like.
Right?
But terrible. But definitely on people's minds. And then really it wasn't a big thing until the 1960s, and that was considered the dino renaissance. Dinosaur renaissance.
Oh, the
dinosaur renaissance.
That's
a thing.
The dinosaurs
they had their own renaissance. Yeah. They just weren't around to see it, unfortunately.
Yeah, right.
But that's when our scientific understanding of dinosaurs took off. We had been looking at their bones before, but there wasn't really paleontology until then. It became, these things are these are not just lizards. These are something more than that. So because of the more realistic perspective we were getting through science, it then led to a more realistic portrayal of these things in pop culture, which led to an increased interest in even more pop culture. In the 1980s, of course, was Land Before Time, which took dinosaurs into the hearts of all children and also destroyed them at the same time.
Abandonment issues, everything, millennials.
I had to explain this whole movie to my 3-year-old the other day and was like, this is insanely heavy. They actually added I was like doing some research. They actually added a part into that movie I think it was post-production, where that old dinosaur is explaining to Littlefoot that his mom didn't leave him on purpose.
Oh, okay. I will say
they added that in.
Helps.
Because they were like, we actually don't know if kids are going to be able to handle this without some more.
They're like, we see what it did to the millennials. We probably should go back and fix this.
Yeah. And it's a fantastic explanation of the circle of life and death before Lion King. Okay.
Oh, yeah.
Then come the 1990s, which is dino explosion in pop culture. So in 1991, it was Jim Henson's Dinosaurs show, which I wasn't really allowed to watch, but definitely did like sneak in every once in a while.
Okay. Have you watched it now since as an
adult?
No,
but I should.
You should, because that is definitely one of those shows where you go back and there's scenes where the teenager, you don't pick up on the humor as a kid. And so there's one where the teenager, Robbie, he gets caught at school eating plants. And then it's totally a pot reference because at one point he skips out on school. He's laying out in this field just, it's amazing. Totally high as a kite. But you don't pick up on that as a kid. You're like, whoa, what's in that plant that he just ate? So definitely go back and watch it as an adult. My son Luke and I, he's in 3rd grade. He watches it now. It's way funnier for me than what it ever was.
I'm sure.
He still laughs because he thinks it's funny, but it is so funny as an adult.
Stuff is just so freaking cool.
Right.
And then in 1993 was 2 very important movies in my lifetime. One was not important for the world, but for me, in 1993, We're Back came out. It was one of the first movies I ever saw in the movie theater, and that is an animated dinosaur movie.
It is, yeah.
It's so good. Also very scary. I actually don't think Alora is ready for that one yet. There's some twisted stuff that happens in that movie, but it's also hilarious. Great 90s, early 90s, so 90s. When you watch that movie, you're like, oh my gosh, the references of the pop culture in that, because it's supposed to be hip in the... Anyway. So in 1993, that came out, and Jurassic Park. So Jurassic Park became a global cultural phenomenon, appealing to audience of all ages and backgrounds. Nothing like that had ever been seen before that made it that appealing to that wide of a range, to that many different countries, and then the merchandise that came from that. It used to be like dinosaurs were like a niche thing, then everybody needed dinosaur stuff.
It was the Star Wars of the 90s, how Star Wars and all that came out.
Global
and it just
cultural phenomena.
Yeah.
You didn't even have to like sci-fi, right, to like Star Wars.
Yeah.
And you don't even really have to like dinosaurs to like Jurassic Park. So like...
Yeah.
And this appeal since then has not stopped. Dinosaurs are here to stay in our culture, particularly for children, but also still for adults. You'll see there's dinosaur clothes, the merchandise. It's, of course, a giant market for such a thing. And we can still see this isn't stopping because Jurassic Park is coming out with another one. So, they're not letting it die.
No, they're not letting it die. Or I would have been fine because Dr. Grant and Statler kissed, and I could have let it go. I would have died happy. That concluded, but then they were like redoing it and a different spin.
Katy sent me the trailer. It does look epic. I just think it's hilarious the things that they do in these movies that have to make it. This one's got to be bigger and better, and these dinosaurs are the scariest we've ever seen.
Yeah, they just keep topping it. They just keep
dinosaurs.
Going.
You're like, what are you talking about?
Yeah, right.
These ones killed their parents. These ones, like, what? They're unredeemable dinosaurs.
Yeah, right.
It's the ones.
There's no good flip side to these dinosaurs.
They had to make dinosaurs in the last couple that were to be mean enough. Anyway.
Right.
But it is coming out this summer. Not a plug, but if you want to keep going on the dinosaur train, here we go.
But it is. If anybody in Fort Worth, and we have a lot of Fort Worth listeners all of a sudden. So
I'll be down to listen to anybody here in the DC, Pennsylvania, Maryland. Yeah, hit me up. We'll go see Jurassic Park. That'd be hilarious. As like a Nature Nerd Nation team.
Yeah, get together.
Yeah. We all just start ripping the movie apart as we watch it and enjoy it. But
scientifically accurate.
Gosh, dang it, Dimetrodon was not around at the same time.
Right.
Anyway. So yeah, that's why we love dinosaurs, probably.
Probably. Well, even though lore folk is more on the pop culture of it, the scientific understanding of it and how it evolved, lore touched on it for most of history anyway. Dinosaurs, whenever we first just started discovering fossils, we started just thinking that they were just slow-moving reptiles from the earth like giant lizards. It's all that we really thought that they were. But yeah, people we had
cool, another cool fossil.
It's just this thing. It's this big dead old animal. And they portrayed them very much so as just slow moving, just again, how Laura said in the early depictions of books and films, they just thought they were just slow, not interesting, and really not entertaining at all. So in this dinosaur renaissance, apparently, when the tide really started to take a dramatic turn, because one of the biggest breakthroughs, I would say scientifically, came with the discovery of evidence linking dinosaurs to modern birds. And that was in the 1990s.
I was going to say, that wasn't even that long ago. I mean, to some of our listeners,
in the 90s,
probably, but...
What?
To some of our listeners, maybe, but for most of us,
They're like, that was
before
I was born. But yeah, so in the 90s, the series of fossil finds in China, they were the ones that revealed that dinosaurs that were covered in feathers. the Zoopteryx, the Caudopteryx, and the Microraptors that they started finding, these were the ones that were just like undeniable, almost like a print of these feathers that were like, hold up, wait a minute. These aren't slow, lumbering, scaly creatures. They have feathers. And that's when it really took a turn. And that's whenever we started talking about the whole dinosaur to bird theory. For a long time, scientists considered birds were a completely separate evolutionary branch. But now it's clear that birds are, in fact, living dinosaurs. This insight has really revolutionized how we view dinosaurs, not just as extinct animals, but the direct evolutionary ancestor to birds we see today. And we know, at least I know, that many of the dinosaurs within Jurassic Park, like Velociraptor, the ones that they portray as a velociraptor in the movie, that's not a velociraptor. Velociraptors are turkey-sized, definitely covered with feathers, so they're significantly smaller. And they shared a lot of modern traits with modern birds, including the feathers, the hollow bones, and a bird-like respiratory system.
Probably the attitude of a turkey. Like,
right? No.
Jerks.
Oh, right? Yeah. What is it? In the third Jurassic Park, the compies that go after that little kid. That's totally a bird move.
1000%.
Like to just swarm and attack. Such a bird
penguin,
move.
just a thing of penguins.
No, right? Yeah. So once we started to see things like the bird-like respiratory systems and everything, and how did we see all of this? A lot of it is whenever we started to basically take CT scans of bones and started to really study how the structure of bones. Okay, hey, let's look at this a little bit differently, like how are muscles attached? Or hey, things like the Brachiosaurus that we thought for a long time had a straight up neck. They're like, that doesn't actually make sense. So they started to really look at different dinosaurs and say, hey, let's kind of look at this a little bit. We know a lot about science. We should probably put a little bit more effort into
right. Like, I think
dinosaurs.
It became less of, okay, we're putting a puzzle together, to let's base the puzzle on an existing animal, because
and how
or at least
how, it's
how we know
attached.
animals function.
Yeah.
Right? Because this isn't an alien planet. It is still life forms that would have been relatively similar. Body patterns aren't different. They didn't have 8 legs. Yeah, like it's We needed to look at actually how muscles, bones, ligaments work to know how to put things together. And some things, and we talk about this all the time in episodes where we talk about fossils and dinosaurs. But all of this is very much educated guesswork, but we're so much better at it now because of the scientific tools that we have and just what we know about anatomy. It's more of an anatomy thing now than a fossil thing.
Very much so. Yeah, very, very much so. And the anatomy side of it that's the part that has given new insights. Because like Laura said, previously they would find, because you typically aren't going to find a whole dinosaur fossil all intact. And so it was like piecing it together, and we got it so wrong so many times. And we still don't really find whole dead fossilized dinosaurs altogether. Yeah, it's always still bits and pieces. But like Laura said, we're doing a lot more of the anatomy side of things, looking at the actual bone structure, looking at the organ placement, brain size, things like that. And a lot of that has come around because of the CT scanning, but then also computer modeling, 3D printing. We can conceptualize and be like, hey, cool, does this make sense? And kind of 3D print the different things.
Would it balance, right? Like just seeing the difference between when I watched The Land Before Time recently.
Oh, yeah.
With the T-Rex being just upright like Godzilla with its tail dragging. And they were like, actually, that's not how if you look at a chicken, that's not how chickens are walking. They're not like, so
that'd be terrifying. Yeah.
Totally upright.
Yes, right.
But so then now you'll see like T-Rexes are not portrayed that way at all. They lean forward. It's just we know a lot more.
Yeah. And again, it goes back to the anatomy side of things that we're doing. And so anyway, so pop culture, scientists, it's in the science of evolution of dinosaurs. It really has gone hand in hand over time.
I mean, there is some incredible ones out there now too. If you want to see the Apple series with the dinosaurs and things like the one that narrated by David Attenborough.
Yes.
It is insane.
There's some good ones.
What we can do now with CGI to the point where I was like, I can touch that dinosaur. It literally, it was so textured. You know how normally you're watching the old Animal Planet ones where you're like,
yeah.
That's a bad model. But now you're like, this is a sensory experience. Like,
yes, you can see every fiber and every
and like extrapolating animal behavior onto them.
Yep.
It's so fascinating now. They're so much more real today to us because of what we know.
Yeah. And again, most of this has happened within mine and Laura's lifetime and most of our listeners' lifetime that has really catapulted forward where it's gone from, okay, let's just piece these little bones together and hope we get something right, which is not accurate, to even within the last, I would say 10, 15 years it's taken off in a completely different direction of just, hey, this is actually like really neat. And there's some fascinating books that have come out, all sorts of stuff. So anyway, the pop culture of it, good grief. And then the scientific understanding of it, it's definitely evolved side by side.
Yes, right. Because pop culture is relying on the science to say what they look like.
But then also it's vice versa too, because you gotta get funding and things like that from somewhere. So
something.
Yeah. So that's kind of how we've evolved over time. Now that we've kind of talked about the evolution of it, and I talked about the scientific evolution of it, Laura is going to go into what makes the dinosaur a dinosaur and the key traits and everything of it.
Right, because I'm about to blow some minds here, I think. Because it was blowing my mind,
too.
Right? Okay, I just want to say the word dinosaur, and I want you all to take a moment and think about, what are you picturing? Okay, because some of what you're picturing, I'm telling you right now, is not a true dinosaur. What is a dinosaur? First of all, they are a group of reptiles. So let's be clear on that one. Things get muddy here in this evolutionary tree. Especially because, and you listeners know me that have listened to a while, I do love some good classification, okay? But dinosaur classification is a freaking mess that will drag you down a rabbit hole for hours. I couldn't go there. My brain was starting to hurt trying to follow all these family trees because it's changed every decade. Even less because of our understanding. So there is no knowing who came from who for the most part, but in general, group of reptiles. And this giant group of reptiles we're going to refer to back in the day were called archosaurs, meaning ruling reptiles. So back then, and this is just a giant catch-all group for all of these. This is not just dinosaurs. Archosaurs were more than the dinosaurs. This is where you find the most recent common ancestor between crocodiles and birds in the archosaurs. But then they started
can you explain what a common ancestor is?
Oh yeah, sure.
I think... Yeah. Okay, because just to clarify, because I know we talked about that recently in another episode, but I want to let's just clarify that so people understand.
First episode. So there's the misconception with evolution that everything came from the same. It's a linear thing almost, even.
Yeah. Linear is a good way to describe it.
Yeah. So we're not saying that birds came from crocodiles. No, they have a common ancestor. So you go back the family tree, think of the branches back and back and back and back and back until finally you get to a point where there was some creature that then evolved in two different ways. One was the crocodile way and one was the bird way. So it wasn't a crocodile and it wasn't a bird. It was just a common ancestor. And the bird-like branch, when these things started to apart, when the archosaurs started to evolve, the bird-like group became Dinosauria. That's why crocodiles still exist. Mm-hmm. They didn't disappear. They were their own branch. The birds and dinosaurs are their own branch of these reptiles. Now that we have, they're reptiles, dinosaurs. This is a group of them. But they're more than just any old reptile. But there actually isn't much that makes them very specific because of a couple reasons we'll get into. But basically, it just comes down to the anatomy. The anatomy of a dinosaur or the definition of a dinosaur is essentially any non-avian dinosaur is an extinct terrestrial animal that walked with its legs up and down. All right, so picture, when you think of a crocodile, you're thinking like an animal that's kind of squat and its legs are out to the side. They're splayed. Yeah. If you look at their bones, they are splayed. A dinosaur, they had... Think of our hip bones. We have a femur with a ball and joint socket. That's what dinosaurs had. It allowed them to not be splayed, but to put their legs under their bodies and distribute that weight, making them use way less energy to walk around. So they were just more energy efficient and better weight support, allowing them to get larger because they could get their legs under all of this weight. And that's mostly it. It's literally just reptiles that could walk with their legs perpendicular to their body. Okay. But a little bit more
Dinosaurs.
like dinosaurs. And you're like, okay, how was that mind-blowing at all? Okay. But, and Katie's going to get into this more a little bit later, but it's that, which is all dealing with hip structure, right? It's the way their hips work, allowing their legs to be like this. They're divided into two groups, which Katie's going to get into, but one is the lizard-hipped group, and one is the bird-hipped group, which ironically, the bird-hipped group is less related to birds than the lizard-hipped group, which that's confusing. But
again, classification scientists, it's hard. Difficult to make up our minds,
Other than that, features can vary, and many ancient reptiles had similarities with what we consider true dinosaurs. That's why it's important to look at several features. When examining fossils or any new kind of find, we're like, is it a dinosaur or is it just one of those archosaur reptiles? They're looking at a couple of different things. The behavior of dinosaurs was all the same. They almost all lived on land with a very few exceptions. So whatever dinosaurs you're right now thinking of that did not live on the land, like the plesiosaur or megalodon or whatever, not a dinosaur. They lived in the water. You can immediately nix that one off. That was a giant reptile. They also all laid eggs, so no live births or anything like that. The other major limiting factor that could give you a clue when you find a fossil of is it a dinosaur is when was it alive, because dinosaurs were only alive during a very specific period. Too early and it's just an archosaur. Too late and it's probably just a bird.
Probably, bird.
It's
a bird.
So what isn't a dinosaur? Most people are thinking the Triceratops, dinosaur. The Brachiosaurus, dinosaur. Like T-Rex, dinosaur. But I think a lot of people also think of dinosaurs as the pterosaurs, which are the pterodactyl. The flying ones, anything flying, not a dinosaur. That's a flying reptile.
Should have just been this whole episode. We just name a thing. It's like, not a dinosaur. Dinosaur. Not a dinosaur. Dinosaur.
Yeah. Well, because, again, it's in the movies. What else would you call such a thing? It's a giant flying reptile, not a dinosaur. Because its hips aren't under its body structure is wrong. Anything
its hips. It's like, come here, pterodactyl.
Not allowed
look at your hips.
In that true dinosaur group. Gotta have them hips.
Gotta have those good hips.
Anything in the ocean, not a dinosaur. Giant reptile, archosaur. And then the Dimetrodon, which you may remember from, is that in the first Jurassic Park movie? There might be one. I don't know. You guys have definitely probably seen one around. It's got that giant sail on the back of it. It's not the Spinosaurus. It's like the one that looks like a crocodile with a big sail on the back. That one, not a dinosaur. Looks like a dinosaur, not a dinosaur.
It's gonna be you the whole episode. Not a dinosaur. Yeah. Not a dinosaur.
It's like a compulsion. Not a dinosaur. That's what it'll be like going to Jurassic Park with me, so you might rethink anything about coming with me.
Right? Not a dinosaur.
Because that
would make a fun drinking game.
Legs. Oh my gosh, yes it would. But probably not safe to do at the movie theater. No, just in case.
I don't know. What do your movie theaters up there not serve alcohol?
Yeah, some of them do, but I'm sure you can't get wasted in public. Like
wow, guys, the cop shows up. What were you guys doing that you're so drunk? We were playing Not a Dinosaur, It's a Dinosaur.
At the Jurassic Park premiere, yeah. Nerds.
There's a lot of not a dinosaurs.
It's anytime you see a human, not a dinosaur. Just an excuse. Jeez, wasting the first 10 minutes. Just alcohol poisoning by the first 20. So that thing is actually barely even, it is an ancient reptile, but it's actually more closely related to us than it is to dinosaurs, apparently. It's like a proto-mammal. Anyway, not a dinosaur.
I didn't know that.
Yeah.
Well, there goes my rabbit hole. I'm going down tonight.
Right. Not a dinosaur.
Not a dinosaur.
So yeah, that's it. That's it. What makes a dinosaur? The hips and the legs being underneath, and that they must be living on land.
Now remember too, whenever Laura's saying what makes it a dinosaur,
we have to remember dinosaur, right? Because a lot of things
a true dinosaur, but also it's like what makes that true dinosaur unique. And so there are going to be characteristics that dinosaurs, any of the archosaurs that they're going to share.
Yes,
you know what I mean? Like
right.
Yeah, and
like
so
egg laying
there's
is a thing between all reptiles.
All of them, and they do have scales, things like. So there are. It's not like that was the only thing. That was the unique thing that made them stand apart from those other ones.
Yeah.
So like Laura said, I'm going to go into then, there's two of the dinosaurs, the actual dinosaurs. There's two main branches that are very, very broadly classified.
And they keep switching around too, believe me. Look at those trees, man. My gosh. I mean, those two groups,
yeah.
But what's in them is like... Blah, 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 blah.
Yeah, so there's a lot of branch offs. So I'm going to go over the main characteristics of the two big ones, and then I'm going to break those two big groups down a little bit smaller, not getting into anything crazy because, again, it gets muddy and, crazy quick. The two major orders are the Saurischias and the Ornithischias. So these groups are based on, like Laura said, the hip structures, which is the key trait for paleontologists when distinguishing between the different types of dinosaurs. So the Saurischias, or the lizard hip dinosaurs, Greek words, the sauros, lizard, ischion, hip joint, referring to the lizard-like arrangement of the bones in their hips. The Saurischias include some of the more famous dinosaurs, like the T-Rex, Brachiosaurus, and this group is divided into two subgroups, the theropods, which are the bipedal, often carnivorous dinosaurs like T-Rex, the little velociraptor, Allosaurus, those things.
Yeah.
Many theropods are known for their agility, their sharp teeth, and predatory habits. Some, like the Archaeopteryx, even show early signs of flight, linking dinosaurs to modern birds. Archaeopteryx was one of the... when we started finding Archaeopteryx like fossils, for so many different reasons, that one became very popular. It was one of the earlier ones that we could see.
It's just like when we found Lucy for our understanding of where humans come from, right? Like,
but the Archaeopteryx, we found more of the Archaeopteryx than we did Lucy. Yeah. Let's be real. We found like a cheekbone or something. You know what I mean? For Lucy, like it was like a small fragment of something. But like Archaeopteryx, we found
just a print like it got run over by a steamroller. Just
it
was like a perfect iron. Like
it does.
God was like, they are floundering down there.
They are so wrong. Let me just smash this little guy. Give him a hint.
Throw him a freaking bone here.
Yeah, he gets to heaven. He's, what did I do? He's like, listen, just bear with me here, man. Did it. Yeah, the humans, man, they were really struggling down the road. So your sacrifice.
Meanwhile, guys, don't get us confused with the people who also do believe that he put the dinosaur fossils there to confuse us.
Oh yeah. Yes,
don't think that.
No. Yeah. Laura and I just jest. We jest because it's way funnier to think of things like this. It's way funnier to think of it as this way. So then within the Saurischias, there's also the theropods, and then there's the sauropodomorphs. Sauropodomorphs. I was like, I'm missing syllables in there. Yeah. So those are the long-necked herbivore giants like the Brachiosaurus, Apatosaurus, and the Dilophosaurus.
At least that was my favorite as a kid. If you had asked me my favorite dinosaur as a kid, it would have been a Brontosaurus, which tragically no longer exists. Although didn't they just they just renamed a they named a new one that now, I think, or something.
Oh really? Yeah, because they morphed it. Didn't they take that one and
they realized they had built it wrong or whatever.
Yeah. So that totally makes sense that would have been your favorite, because I was 100%. Even though I didn't hit like a hardcore dinosaur phase until I was older, from day one I was hardcore Velociraptor, T-Rex.
Of course,
I totally
that was my brother. Like the hyper one. But also, actually, me now, it would have been, I can't believe that I didn't like the large predator, because that's what I like, real live animals. I like large predator animals. I like cats. I like wolves. I just like that main character energy that Littlefoot had going on, I think, is what it was.
It was really cute. I can't blame you. There was the lizard hip, like we said, the T-Rex and everything like that. And then there was the Ornithischias, which are the bird hip dinosaurs. So the Ornithischias, they derive from the Greek word ornithology, just like we have today, birds. And ischion, again, hip joint, referring to the more bird-like hip structure in the dinosaurs. Interestingly enough, like Laura said, despite the name, they're not really the direct ancestors of the modern birds that we know today. It's the other ones that we see. So this group includes the herbivorous dinosaurs with a wide range of adaptations, such as Triceratops, Stegosaurus, Ankylosaurus. Some of the key groups in this one, again, I didn't name all the key groups of the Saurischias because there's a lot. The theropods and the other one that I can't, there's too many syllables there for me. But for this group, some of the key ones, the Therophoras, which are the armored dinosaurs, like the Stegosaurus and the Ankylosaurus, Ceratopsias, which is Triceratops, and the Ornithopodas, which are the dinosaurs like Iguanodon, Hadrosaurus,
and stuff, probably.
Yeah, the other duck-billed ones. So why does that hip structure and that classification matter? Well, again, understanding how dinosaurs are classified, it helps scientists be able to paint a clear picture of how they evolved then. Because again, think about what we were talking about earlier about the anatomy side of everything. All right. It's so important to understand and study evolution because we're going to get it wrong. But then the more we learn about it, the more we start to try to get things right later on. But it's through all that learning that we figure these things out. So some of the things like the classification system provides insight into things like behavior, diet, adaptations. So this hip joint, these are the bird-like hips, these are the lizard-like hips. We can kind of get more clues into things that they ate, what their behaviors were like.
Bodies just show behavior.
Yes,
like
it definitely does.
What you eat, where you live, all that stuff.
Yep. And so being able to piece all those together, that's why those hip structures were so important because, again, yes, it classifies things structurally into one or the other, but then it helps us to try to understand the behavior, the social aspects. If there weren't, do they live in herds? Do they not? Based upon current understanding of today, we can make educated guesses as to what these things were back then to understand. So,
and speaking of where we've been, I'm ready to dive into the geological timescale. No.
Here we go.
But yes, so remember when I said that to know if you're looking at a dinosaur, you must be in a specific time frame because dinosaurs haven't always been around. They only lived during the Mesozoic era.
And I think people forget that. People just think dinosaurs old, they've been around, they were around forever. They really weren't around all that long, unfortunately.
Well, yeah, in the grand scale of things, yeah.
Yes, in the grand scale of things, yeah.
Because there has been 4 eras of Earth. We've talked about these in the past too, when we talked about the formation of Earth in one of our episodes and things like that. But we are talking about number 3, the Mesozoic, which was 252 to 66 million years ago. So that's a 200 million year time period. That's a freaking forever, but not in this grand scheme of the whole planet.
Yeah, not in the grand scheme of things, yeah.
And then eras are always divided into periods. So the 3 periods within the Mesozoic are the Triassic, the Jurassic, and the Cretaceous. We are definitely familiar with Jurassic because of Jurassic Park, but that's not the only one that contained the dinosaurs. And a lot of people imagine these dinosaurs as all coexisting at the exact same time, which is also not true, just like any other animals out there. So you might not have seen the animals in Jurassic Park. They did not all exist at the same time, nor were they all dinosaurs, we now know.
Not a dinosaur. Shot.
First comes the Triassic period. This is where the appearance of the first true dinos happens, but not until near the end of the Triassic period. So we're not talking, they haven't been around since 252 million years ago. They were closer in than that. They were not the dominant life form during this period. And if you're trying to have a context of what was it like then, this is when Pangaea formed, that giant supercontinent. All the land was just clumped into one section. Huge continent, which meant insanely varied climates, some that were pretty extreme, like deserts, or hot, dry, all things like that. And life forms that were there with the early dinosaurs, the plant life was just cycads, which we've talked about in a past episode, conifers and ferns, all those all seed-bearing stuff. Nothing with flowers yet. And then the other archosaurs. Though the archosaurs, the ancient reptiles and the things before that, they were still dominating during this time. And then the Triassic ended with an extinction event. These keep happening. Extinction events constantly happen. It's normal for background extinction to constantly be happening, and then there are larger extinction events.
Yeah.
Then jump into the Jurassic period. This is when dinosaurs really began to reign as the dominant terrestrial life form. Again, terrestrial, not in the ocean.
Not a dinosaur.
So we just scream, not a dinosaur. It's like our passcode. They thrived and diversified into large herbivores and large carnivores, so they started to really branch apart. And what was happening on Earth is the continents at this point are now starting to drift apart. So they're going into 2 big continents. They're creating new oceans as they drift apart. There's large, shallow seas, but everything is pretty mild. There's no ice caps, which means that the plants are also starting to diversify more, but still all those gymnosperms, all the cycads, conifers, also some ginkgo trees. And the very first of the flowering plants, very minor, not taking over yet, just dabbling. There was a wide variety of plant life because there was more rainfall and higher temperatures during this period. And again, still lots of other archosaurs around. And then finally, the Cretaceous period. This is the longest period of all the Mesozoic. It's not just divided into 3 even chunks. The Cretaceous is the longest. This is when the dinosaurs really were like fully diverse. And
we're here.
And ironically, this is actually the time of the T-Rex. Really, it should be Cretaceous Park, not Jurassic Park. Sorry. I don't know if it has the same ring. Cretaceous? It's a cool word. I don't know.
Yeah.
But yeah, the Jurassic, not so much. The geography, again, the continent, now we're getting closer to modern day. Like the continents are already, they're ending up where they're going to be. There's just a little bit of variation with India floating around and things like that. There's still lots of shallow inland seas. All this drifting is causing volcanic eruptions. Mountains are forming. It's a time of change. And the Earth is warm. It is most of Earth is tropical to subtropical. No ice caps. So this is probably what Earth is going to be like again soon. But as we're talking about mass extinction events.
Having so much fun about dinosaurs, and then you just
but listen, this was the time of the dinosaurs, and they were thriving. I'm just saying that if the dinosaurs could do it, we'll probably be just fine. This is when flowering plants were like, this is my time to shine. Flowering plants came out, started appearing everywhere, and it was a huge deal because this was a game changer for food chains because all those herbivore dinosaurs were like, I want some of those plants. And so they started evolving to eat those plants, which then flipped around all these food chains. It was just like the rainforest, like everywhere, super lush. Lots of other archosaurs, and now the very first little mammals. And then the Cretaceous period ended with the giant extinction event called the Katy extinction event, which we're not going to dive too much into today, but is basically the end of almost all life at the time, but all non-avian dinosaurs.
Yes.
And that is the time of the dinos.
We talked a little bit earlier about the unique adaptations as far as the hip bones go, and then I mentioned how there's adaptations that they had that kind of went across the broader, and they jumped across the variety of animals at the time. So we talked about bipedalism and walking on the 2 legs. A lot of the animals, we don't really get into this later, so I guess I can go into this a little bit. Hollow bones. That's one of the things that we know about birds today is they have hollow bones. Many of the dinosaurs had hollow bones. Not all of them, particularly those in the theropod group, had hollow bones though. And obviously
there's some links there.
No, yeah, definitely. And that's whenever we were like, oh my goodness, these, not only were we seeing feather imprints, but now when we're looking at these bones, we're seeing, okay, they're hollow, which makes them a lot lighter without sacrificing the strength. Because it's, again, don't think of it as the modern day hollow bone. If you guys have ever seen a bird bone, it's not quite the same as that.
Well, right, and it's not even really technically completely hollow either. But if you listen to our adaptations for flight episode, we go into hollow bones.
You'll hear a little bit more. Yeah, it's not like a rigatoni noodle, you know?
Yeah, just
like
through like
yeah, right. just blowing through a T-Rex bone. No. It definitely can take the burden of excessive weight, especially if you figure how huge some of these dinosaurs were, like the long necks and stuff. But again, yes, it's heavy. Yes, it's a lot of bone. It's a lot of weight that it needs to support. But could you imagine how much heavier that dinosaur would have been if its bones weren't partially hollow? It would just be absolutely insane.
Well, plus, if it was anything like birds, it also allowed them to get more oxygen in probably an environment. So I forgot to mention that at least because it seemed irrelevant at the time, but now saying this, during the Mesozoic era and how warm it was, there was a lot more carbon dioxide in the atmosphere, making things warmer, the whole greenhouse effect thing. So there was not as much oxygen. Therefore,
yeah, so they needed to take in...
You probably are. You needed to take in more oxygen just to be able to survive.
Yeah, and so that's whenever they started evolving things very similar to what we see as the bird, like I said, go into that one next actually, the specialized breathing. And that not only came into place, like Laura said, because of the atmosphere that they live in, but then also you figure these dinosaurs were ginormous, okay? Being able to breathe, just being able to breathe to be able to supply enough oxygen to something that big, it takes again, go back and listen to our episode that we did on birds and flight adaptations. And it's a little bit more structured like that, where it's like multi-chamber sacs, and it's when you breathe in, you're inhaling and exhaling at the same time.
Yeah.
And so it goes in like a circular motion. And so because of that, you're able to keep, like Laura said, bringing a lot more oxygen into your body, oxygenate your blood a lot quicker, because you're huge. You need a lot more oxygen in a place where it doesn't have a whole lot of oxygen.
Yeah.
So your body needs to adapt to be able to bring in.
Like a yak up in the Himalayas. Like, you know, but the opposite. Like, I mean, yeah.
No, you're right. You're right. Like a yak. It is, though.
For all of our Himalayan listeners out there, you know, like a yak. Like,
for all of our Himalayan. I'm going to have to look. We're listening to it 102.
There's
got
to be some people from
countries.
Nepal that listen to us.
Yeah,
Not that you all live in the Himalayas either.
I'm pretty sure we do have some folks in Nepal that listen to us, and like in quite numbers too. It's not just a little amount, but so they adapted. And then again, that's what we were like when we started doing CT scans and really studying the bones and the structures. These things, like the dinosaurs, were like, they look a lot like birds. And it's whenever we started to see pieces and parts breathing and how you can see their hollow bones. Again, feathers, not just for the insulating. And again, a lot of the theropods, the Archaeopteryx, Velociraptor, feathers, not just used for flight, but they used them for insulation, display, because everybody thinks dinosaurs hot, humid, and that's not necessarily always the case. It wasn't that it was just hot, humid everywhere. There were parts that was colder, and again, just like we have birds today that use it in mating. Why wouldn't have they used it in mating back then? And so things like that are starting to shape how we think of dinosaur behavior, which then behavior plays a huge part into, okay, now that we understand their bone structure and everything, and their teeth, their specialized teeth that they have, all these pieces and part are now going into the behavior. How are they interacting with now? Then mammals come around and plants come around and all these different pieces and parts come around. And we start plugging all of these things together. It starts to paint a much better picture of how things were back then. But it takes all these little pieces and parts and putting things together for it to really make sense.
Yeah.
Some other adaptations that I'll briefly touch on is speed and agility. Again, for a long time, we thought the dinosaurs were these slow things. I mean, even watch Jurassic Park and the T-Rex is like boom, boom. You know, that's the cinematic feel.
I mean, it's
of it.
chasing a car, but it can't reach the car.
Yeah.
Yeah.
No, right? Of course, you're going to have some animals, just like we have today, that are going to be slower moving. But most of them were like really fast.
I mean, even an elephant can be fast.
Yeah, when it wants to, for sure. I mean, a hippo, for crying out loud. Like, those things fly. A manatee, for crying out loud. What do you think of some of the slowest animals on Earth? But no, if you've never seen a manatee full speed, go to YouTube and just type in full speed manatee.
Full speed manatee is definitely a good band name.
No, full throttle manatee. A manatee. But it goes so fast, and people don't. It's the same thing with the dinosaurs. There's gonna be slow animals, there's gonna be fast animals, but there's gonna be things
it's
like.
Kind of how. Did you ever watch King Kong, the newer King Kong?
Oh yeah,
when there's that stampede of the sauropods.
Yeah,
they were pretty freaking fast and terrifying. Although when they all started tripping and they're like, whoa.
Yeah. Well, and let's just get this out of the way. So I said earlier about how in Jurassic Park, how velociraptors that they were showing, that's not a velociraptor because velociraptors are turkey-like. The dinosaur that you picture that they're showing you then is basically what we call the Deinonychus right now. But again, the Deinonychus, honestly, if they would have made it what we have, our understanding now with the feathers and everything, I'm sorry, way more terrifying.
Oh, yeah.
Way, 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 way more terrifying. And those things were freaking fast. And they were that big. It was just saying
we didn't know.
Deinonychus wasn't as catchy as Velociraptor. Yeah, right? It sounds way vicious. But the Deinonychus, again, it was that big. Just think of that big, but also feathers. It did have that talon and stuff.
It's a freaking cassowary. That's what it is.
Yeah, it's a cassowary. Yeah. And so there were a lot of features. Yeah, think of how fast a cassowary is. So anyway, so that's a little bit about the adaptations and how it fits into that timeline as a whole. Because again, we have these timelines, but then as we start to piece apart and look at those different adaptations and how those different adaptations evolved over time, you can see okay, this adaptation came up at this time, this one came at this one. And then you can kind of see how Laura was saying, oh, all of a sudden they started eating flowers, they started eating this. Well, you can see that change come with their teeth.
Yeah.
Or you can see like how they got faster because they had to adapt for XYZ equivalent. So a lot of these unique features that dinosaurs evolved and adapted to have were all because of the changing of the surroundings. And because we have these really cool fossil records of both plants, of animals, we can look back and see those changes through the fossil records, which is pretty cool.
I feel like you should go first with your debunking myth, only because mine is literally an end event.
I mean, that would make sense.
That
would make sense. That would make sense. So I think I said mine earlier, or one of us said it. So the myth that I'm going to talk about real quick, which is surprising that I didn't go to the Deinonychus, because that is like favorite dinosaur fact that anybody's like Jurassic Park. I'm like, did you know that's not a velociraptor? That's a Deinonychus, which is like by far one of my favorite dinosaurs because it's so neat. Not a velociraptor. But the one I'm going to be talking about is dinosaurs that were cold-blooded. Because again, we all thought, oh, it's just it's a reptile. Definitely not. Again, we think slow-moving animals that needed external heat to regulate their body temperature, much like modern-day lizards and crocodiles. But as research progressed, that view has changed dramatically and has been largely debunked by paleontologists. So let's just dive into some key features of how we definitely know that dinosaurs was not cold-blooded. Reptiles today are genetically ectothermic, meaning they rely on external heat sources like the sun to regulate their body temperature. This was thought to apply to all dinosaurs, leading to the belief that they were slow-moving, lethargic, and only active during warmer parts of the day when they could bask in the sun. Again, modern-day reptile.
Well, right, and we said at the beginning, dinosaurs are a subgroup of reptiles, but they also then they share common ancestors with birds. So at what point did we transfer from ectothermic to endothermic?
Yep. So I'm going to say that. Yep. As a scientific understanding advanced from this slow, needs sun creature, especially with the discovery of the more detailed fossil evidence and advanced technology, scientists began to rethink the idea of dinosaurs being cold-blooded. So several factors that have led researchers to reconsider the ectothermic model for dinosaurs. One, their bone structure and growth rates. So one of the key pieces of evidence against the cold-blooded theory comes from the study of the actual bones themselves. The bones of dinosaurs show patterns of fast growth, similar to what we see in modern warm-blooded animals, where things like crocodiles, alligators, typical lizard, typical crocodile, very slow, and you can tell that through the growth.
And do you mean bone growth as in just normal bone growth, or like healed bone growth?
Just everything in general.
Okay, because I definitely can see how we would be able to tell the difference in a heal. Because from my experience, when I have a reptile that gets injured, it takes forever to heal.
Yeah, forever.
So we would be able to see that in a broken bone of a reptile. It would take so long if it was cold-blooded. Yeah. But if it was warm-blooded, bones did it faster.
Yeah, I'm sure they didn't find any T-Rex with casts on back then.
No, but I'm sure they saw the bone growth. Like, you know what I mean? You see broken bones that have healed in fossils.
So typically the cold-blooded animals, they grow much slower because their metabolism is governed by external temperatures. Think of a snake. All right, it's very slow. They slow move. In contrast, dinosaurs, especially large species like the T-Rex, showed signs of rapid bone development, which is way more consistent with warm-blooded animals that maintain a high metabolic rate. All right, the other thing we saw was their feathers and insulation. Again, the feathers of this discovery of feathers, the feathers of discovery, the discovery of feathers in many theropod dinosaurs such as Velociraptor and Archaeopteryx also challenges the cold-blooded theory. So feathers serve as an insulating layer, which is an adaptation that we associate, again, with warm-blooded creatures. Modern birds, which are descendants of dinosaurs, use feathers to regulate their body temperature.
Right, because you don't need feathers. Feathers wouldn't do anything on a reptile.
Yeah, it would do nothing.
Well, at least for insulation, because they're not, like, the whole point of feathers is that they trap body heat, but you're not giving off body heat as a reptile.
You're bringing in any heat so that you can do anything at all.
In fact, feathers would be the worst thing for you, because then it would block, like...
Yeah, right. Yeah, the feathers would be the worst case situation for a reptile. So the presence of feathers active behavior and hunting. So a lot of cold-blooded animals are typically less active and need to warm up in the sun to become agile. But many dinosaurs, particularly, again, the theropods, were likely active hunters. And again, that's something that in any early depiction, especially of the T-Rex, they were always hunters.
Well, right.
But then we're like, nope. Like, no. You didn't see in Jurassic Park, that T-Rex, he has to go bask in the sun all day, and that's the only way he was able to go eat that guy off the toilet.
Right. And reptiles, because of their slow metabolisms, they don't need to eat very often. So, like...
Yeah, so probably that one guy on the toilet probably would have been pretty good for him.
For a couple days. But
because you figure he ate
not if he was endothermic. You know what I mean? If he's endothermic, he's going to be eating every day.
Yeah, and so you figure too, right before he ate the guy off the toilet. Spoiler alert! I mean, you should have seen it by now.
Yeah.
But right before he ate the guy off the toilet, he also ate that goat. Remember? Yeah. So it was like the guy on the toilet, and he was still hungry.
Oh yeah, because he was still good. And which would be if they were endothermic.
Yeah, which would make way more sense. So again, even if we really weren't going down the road and connecting the dots of, hey, this doesn't really make sense for a cold-blooded animal. We have been portraying them as warm-blooded creatures for a long time. We just haven't been saying it that way.
Yeah.
And the other thing is oxygen and respiration.
Oh, right.
The respiratory system of some dinosaurs, particularly in the sauropods, indicate that they could have supported the metabolic demands of a warm-blooded organism. And some species had a highly efficient system for extracting oxygen from the air, similar to modern birds that we talked about, and mammals, which are known for their higher energy and metabolic needs. The increased oxygen intake would have supported the higher activity levels, faster muscle responses, all traits which we associate to the warm-blooded animals today. So the middle ground, then we have the endothermic or mesothermic. While it's increasingly clear that dinosaurs were not cold-blooded, the debate does still exist over whether they were warm-blooded in the same way as mammals and birds. Some scientists propose that dinosaurs could have been mesothermic, a state somewhere between cold and warm-blooded.
Which is what some sharks
and a mesothermic,
right? I feel like some sharks are. Or
I think
did we talk about that in a shark episode? Or they're truly endothermic? There were some sharks that we were like, isn't this freaky? They can regulate their body temperature.
I don't remember. Tuna? Yeah, great white sharks.
Yeah.
Leatherback sea turtles.
Yeah.
Echidnas. Like...
freaking weird.
Some species of bees. After a quick Google search.
So I definitely remember we talked about the great whites being like mesothermic.
Yeah, I think it was the great whites. Yeah, so they can generate some of their own body heat, but they don't maintain the same constant internal temperature as true warm-blooded animals, something like what we would. So this would mean that many dinosaurs could have been more active and agile than cold-blooded, but they may not have been to the same level of temperature regulation as modern birds or mammals that we have today.
Which makes sense to me because they weren't also dealing with perhaps some of the crazy... They didn't need to evolve to deal with super, super cold. There weren't polar ice caps. You know what I mean?
Yes.
They didn't need to be completely endothermic.
Yes. Yeah, and back and again, whenever you're adapting for survival, it is the need. What do you need? What do you need to do? And so if you don't need to do it, chances are you're not typically, you're not going to evolve it. Yeah. So the mesothermic, it does make sense. We're leaning more towards warm-blooded. We know it's not that they weren't cold-blooded. We know that for sure because it just doesn't make sense. What the fossil evidence is telling us, what we understand about modern animals, it just does not make sense for them to be cold-blooded. So that's my myth debunked.
That's awesome. I love to see the fossil evidence showing the anatomy stuff.
No, right? Yeah, it is neat.
All right, and I'll just wrap it up with our other myth that I just think is so prevalent that most people think about is that all dinosaurs went extinct at the same time. Like we just think about, boom, one day dinosaurs are gone. Of course, that's not how this works. So in the entire Mesozoic period, there were several lesser extinction events, like I even said, in between the periods. It wasn't just as large. It wasn't like when we usually think about the extinction of the dinosaurs, what you're thinking about is this Katy extinction event, which we still don't actually know what happened. We have theories, but we don't know. So while there was this mass extinction event at the end of the Cretaceous period, it wasn't like, bam, all the dinosaurs are dead at once. Yes, vaporized in a certain area if it was the asteroid, but it's not every dinosaur on planet Earth all dead at the same time. Just like through all history, dinosaur species have come and gone. any species of animals. There's rises and falls and declines in populations and all things. Even before this massive extinction event, there were some species that came and went. And it is honestly almost impossible to have a clear picture due to a spotty and layered fossil record. Okay, we are never going to have all the answers. We just never will, because the fossil record, it is snapshots, first of all. It's not like boom, 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 boom. It's snapshots. And it also only tells us stories in the layers. We find them in the rock. So unless we find things together in a rock, we don't know if it's at the same time. So we are left with questions like, did a species get replaced, or did they exist simultaneously? Did they die out, or were the conditions never right again to find a fossil of that species?
Yeah.
Have we
because again, go back and listen to our fossil episode.
How freaking hard it is to make a fossil.
Yeah, it has to have very particular, very
like
particular,
Goldilocks.
Situation for. So the fact that we even have fossils, and as much as we do, other than Archaeopteryx, where was just smash, it is impressive that we even have fossil records to begin with.
Yes.
Yeah, it's fascinating.
Have we just not found the right evidence yet? Because we still have a lot of rock to go through. It's not like we're constantly finding the right place.
We still have a lot of rocks to go through.
That'd be, like, if I was a paleontologist and I had my interns, I'd be like, guys, we still got a lot of rocks
to go through.
And so we can't say for certain the duration of any species. We can't say, okay, T-Rex lived from this time to this time. We can make our educated guesses, but with no clear certainty. And we're talking like, again, this is give or take 50 million years. It's like, it's pretty.
I wish any of my guesses that was appropriate for my field of work. Yeah, give or take 50 million years,
So not only can we not pinpoint when exactly dinosaurs have come and gone, but we don't even know why. The asteroid theory is a very popular one, and it's a good one, but it does not explain some weird anomalies that I would love to dive in a future episode, because certain species were not affected, and that doesn't track with certain things that we see that have happened. There's a lot out there. What could have happened? What actually did end the dinosaurs? Was it disease? Was it the asteroid? Was it something about sterilization and UV? Like all kinds of things, Lots of theories, no concrete answers. And finally, the last part of this myth that all dinosaurs went extinct at the same time is not only do we not know when exactly they did go extinct, and almost definitely not all in one instant, but that they're not all gone. The non-avian dinosaurs are gone. When you hear that term, you're like, non-avian dinosaurs? That's because avian dinosaurs still exist. I found this quote, which I thought perfect, because it's so hard to wrap your brain around this weird concept of what's a reptile, what's a bird, what's a dinosaur, all that. Archaeopteryx, and I think it's Zhaotingia, I could be wrong, the oldest birds known, Archaeopteryx, we've talked a lot about in this episode. They are classified as both dinosaurs and birds, just as humans are both primates and mammals. Okay.
Oh, that's a good way to look at it then. Yeah.
Yeah, because the lines get so blurred, right? When is something, when did birds start being called birds? When they stopped being called reptiles? Like, it's like, I don't know.
Yeah, where did that line?
So, because in that case, then we could say that birds are reptiles. But they're not. At least colloquially. We're not going to tell our kids, oh, actually, did you know? It's a reptile.
Yeah, because again, it's how we defined it now. We defined reptile to have certain characteristics as we knew reptiles now.
Yeah,
now that we're learning.
Yeah, we've made a lot.
Yeah, and now that we've learned so much more about dinosaurs in the past from the evolutionary, it changes. And again, that's why classification with all animals, all plants, any living thing changes all the time, because the more we learn about these things, the more we're like, let's just bump this one over here. Or these two things that we thought were the exact same are actually two different things. Let's split them apart. And so then it just gets crazier and crazier.
Yeah, so in the craziness of classification, technically, it's not that birds are dinosaurs. In a way, yes.
Yeah.
The oldest birds were Archaeopteryx, and they were both dinosaurs and birds. So the fact that birds still exist, they are technically dinosaurs in a weird semantics kind of way. So no, they're not all exist. So yeah, that's the myth that all dinosaurs went extinct at the same time. It's just not true.
that was a good myth. So Laura and I, again, we just wanted to pick on 2 of the myths that you hear a lot.
Yeah.
Of many, many myths. And yeah, the extinction one would be a really cool one to go and a lot,
because it's
a lot deeper
of
in a
cool
whole other episode.
speculation.
Yeah,
with it science-based, but still,
Mm-hmm.
again, no concrete answers because we just don't have them and we never will.
So anyways, guys, that's our dinosaur episode.
Yeah, and how
I feel
like
so much
they're
better.
So yeah, you're like, we finally, because we've talked about dinosaurs so much but never dove into them, and how the discoveries again
shape so much.
And are continuing to shape what we know.
Yeah.
Why do dinosaurs matter? I don't know, because science matters. The more we,
it's just cool. It's just, again, again, it goes back to understanding the past to help shape the future. And then it just like plug all those pieces in.
Right. Well, and using what we know modern day, we're applying it, right? Does it work?
Yeah.
Does what we know work if we apply it back here? So you're also testing what we know. Just, it's very back and forth. There's a lot of applications for such a thing.
Yeah, it definitely is. And so that's why it's really cool to continue to study it, to continue to get answers. Plus it's just neat.
Yes, and
just really cool.
If this is for a kid or an adult, if this is your spark of curiosity, dig it. No pun intended.
But yeah. Well, guys, that wraps up this dinosaur episode. Next week, we're going to have a second week 2 of Cosmic Critters. Mm-hmm. And then after that, we have quite possibly, and you guys thought I was excited about this episode. You have to listen to next week's episode because we'll give you a little bit more of a teaser.
Face of delight when I suggested such a topic. She was like,
"Oh my God, yes, yes." So it's related. Think of this as a part 1. Then we have Cosmic Critters, and then that episode after is kind of a part 2 to this episode. So make sure you guys listen to Cosmic Critters. Again, that's our mini-sode series that we're doing throughout the season. Listen to it next week. And next week, you're talking about Felicity.
Oh, yeah. Felicity.
Yeah.
Felicite.
So, yeah, Felicite. So make sure you guys listen to Cosmic Critters. And then, if anything, yes, Felicite is a great story.
Yeah.
But if anything, listen to that one just so that you can get the teaser for what we're going to be talking about the week after that. Because
I'm my glory. You're like,
I'm so excited for that.
Last 30 seconds.
Yeah, I'm so excited. All right, guys, make sure you go support us on Patreon. If you search for us on YouTube, we have all of our videos where you get to see our faces and everything too. So make sure you go check us out and support us. It brings more dinosaur content your way or other content.
Bye, everybody.